Hello friends, we are continuing with sampling methods. Now we shall discuss the concept of central limit theorem. Central limit theorem. Central limit theorem suggests that when the sample size increases, the sampling distribution of the mean approaches normality regardless of shape of the population distribution. So what is indicated by central limit theorem? What is suggested by central limit theorem? So it suggests that when sample size becomes larger, increases, the sampling distribution of the mean approaches normality regardless of shape of population distribution. This theorem further states that the sampling distribution of any statistics will be nearly normal if a sample size is large enough. And for this purpose, the large enough size of the sample is taken as 30. So when the size of sample is 30 or more, in that case the sampling distribution of the mean approaches normality regardless of shape of population distribution. What is important aspect of central limit theorem? The important aspects are normal distribution is used as an approximation to the sampling distribution when sample size is minimum 30. So when sample size is 30, it is assumed that there is normal distribution. It permits to use the sample statistics to make inferences about population parameters without knowing anything about shape of the frequency distribution of that population. So this theorem permits to make use of the sample statistics for drawing inferences, for making conclusions about the population parameters, and that too without knowing anything about shape of the frequency distribution of that population. If we know the mean and standard deviation of statistics, we can find the mean and standard deviation of sample distribution of that statistics. If sampling distribution is normal, the Z transformation can be used in CLT with following formula. So when sampling distribution is normal, and it is considered normal when sample size is at least 30. In that case, we can make use of Z transformation. So this is Z transformation. Z value is equal to, or Z is equal to mean of statistics, mean of sample minus mean of population divided by standard deviation of the mean. So by using this formula, we can know the Z transformation. Now, central limit theorem. Central limit theorem, we do a case study. So here we have the information. In a bank promotion exam, maximum marks are assumed as 50. The mean score of the candidates is 41.5 and standard deviation is 2.5. For a sample of 50 employees, out of all eligible employees, who appeared in this exam, what is the probability that the mean score will be between 40.5 and 42? So out of all eligible employees who appeared in this exam, if a sample of 50 is taken, what is the possibility, what is the probability that the mean score will be between 40.5 and 42? So this calculation we are to make. In this, population mean is given as 41.5. So here we are given the population mean because this represents all eligible employees and this is represented by mu. And population standard deviation represented by sigma. So this is 2.5. It is here. And the sample size which we have taken, which is represented by small n, it is 50. So this is the given information. Now, probability which we have to study, the range is 40.5 and 42. So this is the probability which we have to study. Standard error of mean. So we can calculate a standard error of mean, and this is calculated like this. Standard deviation divided by square root of number. So number here we have 50, standard deviation we have 2.5. So 2.5 divided by square root of 50. So square root of 50 is 7.07. And in this case, the standard error of the mean is calculated as 0.3536. In this case, the sample distribution is assumed as normal because sample size is more than 30. So we assume that the sample distribution is normal. And when sample distribution is normal, so we can make use of Z transformation. So hence Z transformation, that is Z is equal to this, can be used. Now we can make use of this formula to calculate the probability. So P, this is sample mean 40.5. This is population mean 41.5 divided by standard error of the mean. So divided by standard error of the mean, that is 0.3536. This is less than or equal to Z, and again this is less than or equal to this. So here we have sample mean and we have population mean divided by standard error of the mean. Now we can solve it. So 40.5 minus 41.5, we have minus 1, divided by this, we get this value. So similarly, 40 minus 41.5 divided, so this is 0.5, divided by this value, we get this. So here we have Z1 and Z2. Value of Z1 we here have minus 2.8281, and value of Z2 we have 1.4140. and we have placed it here. From Z value table, we take the value for this and this. From Z value tables, the value for minus 2.8281 is 0.4977. So this is probability value we have taken from Z table. And this value for 1.4140 is 0.4207. Now we can add up. So 0.4977 plus 0.4207. So the total value is 0.9184, or we can say 92%. So there is 92% probability that the mean score of sample will be between 40.5 and 42. And remember, for this purpose, these signs are not taken into consideration, because here we have this minus sign and here we have plus sign. So we are to ignore the signs and add it up to calculate the probability. So here we have calculated the probability at 92%. Well friends, we shall continue with this in the next lecture also. Thank you.